You're watching the free version of SynthEyes Essentials. For projects and footage, head to BorisFX.com for the premium download. Hello, and welcome to the final class of SynthEyes Essentials. We've covered quite some ground in this course so far, and by now you should be able to produce your own high-quality camera tracks. But all those are worth nothing if you can't properly get that data out of SynthEyes into your CG or compositing application. Maybe I should rephrase that. All of those are worth nothing if you can't properly get that data out of SynthEyes into your CG and your compositing application. As you will see later on in the class, the data we generate here can potentially be the base for a lot of imagery that will then, in turn, be used in another application. So hiccups in the export can have huge ripple effects down the pipeline, and those are not good ripples. The first step in ensuring the quality of your export is going through what I would like to call our pre-flight checklist. Going through the list, you can make sure that you took care of all the things that can potentially bite you once you send your export out into the open. So let's go through this list. A proper solve. This one is kind of obvious, but at this stage you should be absolutely sure that the camera move SynthEyes came up with is really close to what happened in the real world, and that the h-pix is below whatever is the bare minimum for the job or task you're working on. In most cases, that means the h-pix should be below 1, not only on average, but uniformly along the entire range. Solve 3D points. The solved points that make up your scene should definitely be part of your export. In some software packages they appear as mere locators, but in others they can be used as nulls or axes to attach elements like geometry or images to. A lens distortion workflow. We talked extensively about how to calculate lens distortion and how compensating for it can improve the quality of your solve. But all of this is for naught if you don't share that data with the pipeline in a way that other software or artists need it. That means making deliberate choices on how to distribute the lens distortion and if and how much overscan needs to be supplied. A coordinate system. We learned that SynthEyes is unit agnostic and also can work with both a Z-up and a Y-up coordinate system. But not every software is so flexible. To make sure your camera and your geometry are not showing up teeny tiny and upside down, you need to be aware of these parameters on export. Also, make sure that you locked your coordinate system with proper constraints before exporting. Why? Because it can be nerve-wracking if you already started working on an exported scene in another software, only to find out that you have to realign everything because a revised version of the camera solve comes in with a completely new coordinate system. Reference geometry. It should be obvious that for a proper QC you would need reference geometry anyhow, but if, for example, a scene exported from SynthEyes does not align correctly, then reference geometry might be another artist's best clue on how to properly change parameters inside their software to make the scene fit. Also, it can save them a lot of time as they don't have to recreate what you already have at your fingertips. Now that we successfully got through our pre-flight checklist, we should talk about our destinations. By that, I mean the actual elements we want to export and the software we want to export to. In the first class we did a kind of fire and forget export to After Effects, but that honestly is less than the bare minimum. Why? With just a script, even with one as convenient as the one we got from the After Effects JavaScript exporter, we can neither verify the accuracy of the export nor change to any other application than just After Effects. So I would propose the following for us to export. Reference movie or file sequence. This is basically a play blast of your sequence with your reference geometry, the ground plane, the frame counter, and optionally any other metadata of interest burned into the image. It does not need to be a high-quality 16-bit OpenEXR or alike, but it should be frame accurate so that you can compare it against the output of the solve in the application you exported to. Undistorted image sequence. This one is more important when exporting for CG applications, as compared to compositing applications. But the CG artist will need the image as a backdrop for his scene. It'll also give him the precise information on the resolution he needs to render at to avoid any problems once his image is redistorted in compositing. Compositing, on the other hand, will most likely use the original footage and undistort themselves to avoid any unnecessary filtering. Software-agnostic camera, geometry, and lens data. There are a lot of open industry standards that SynthEyes can export to and that virtually any 3D application that can make use of 3D data can import. The two most important ones would be FBX and Alembic. While they are somewhat limited by the type of data that they can contain, I would consider it common courtesy to include these in your export as a fallback, as it gives anybody in the pipeline the flexibility to use your data in a number of software packages without having to come back to you and ask for yet another export. And never forget about lens distortion. While ST maps don't offer any post-export editability, they are not only readable by all relevant CG and compositing applications, they also work with any kind of lens distortion model. Software-specific data. While the first three items on our list would be enough to pick up the shot and club something together, the dedicated export scripts from SynthEyes offer a lot more data and convenience. SynthEyes has got a very extensive exporter list, and it is very likely that you'll find exactly the exporter that you need. In part 2 and 3 of this class, we will deep dive into a couple of these exporters, showing you exactly how they work. See you there.